reactant 1% तो react कर चुका है, जो बचा होगा that would be 1 minus alpha. Alpha is the इतना percentage dissociate और इतना amount dissociate हो चुका है. 1 minus alpha हमने किया because इतना left, इतना बचा होगा of the reactant. This मतलब that is why I multiplied this with the concentration term. You are saying it should be C minus alpha. No, that won't happen. C minus alpha would remain as it is. That alpha I have not converted into the concentration term. First I have like taken in with respect to the degree of dissociation. उसको confuse मत करो please. हाँ, alpha is the degree of ionization or degree of dissociation. This is the amount or इतना amount ionized या dissociate हुआ है. In order to convert that into the concentration, I have multiplied that with the concentration given to us. Abhi we'll do a numerical, then you will be able to understand more. Okay. I just want you to understand how we have come up to this expression. And there is one condition in this expression: if alpha is very small, if the value of alpha is very small, which is generally the case, you can take 1 minus alpha to be 1 because alpha is very small as compared to 1. With this, your Ka becomes C alpha square upon में 1. So therefore, your alpha square is nothing but Ka by C, or alpha is under root of Ka by C. This is how your degree of dissociation or ionization related to the ionization constant. Okay. Now is there any law you call this is a law? You know what is this called? Ostwald dilution law. Okay, this is known as Ostwald dilution law. For weak acids. ठीक है, this is Ostwald dilution law for weak acids. Now I want you to write down a numerical so that we can understand this concept more. Why I have taken 1 minus alpha and why I have multiplied that with the concentration. Write down, calculate the degree of dissociation the degree of dissociation. You have to find alpha and the concentration of H3O plus ions when you are provided with 0.01 molar solution of formic acid. I hope everyone knows what is formic acid. ठीक है, so first thing which comes under our mind is we should have an equation. Okay, I'm not going to take water here because water का concentration remains constant. So this will dissociate to give you formate ions and H plus ions. Okay, so what would be the initial concentration? Concentration of formic acid. Good, 0 and 0. Okay. Fine. Now let us talk about concentration at equilibrium. If alpha is the degree of dissociation, that means alpha amount of 0.01% has dissociated. So if alpha amount has been there at equilibrium, तो इसमें से कितना हो जाएगा 1 minus alpha. To convert this into concentration, I will multiply this with 0.01. Similarly, this will become 0.01. So this is the concentration of formate ions, this is the concentration of the acid. You have to calculate this and this. ठीक है, we are provided with concentration of acetic acid. Now we know our degree of dissociation is related to dissociation constant and concentration through this expression. We have this value, but we don't have this value. Matlab I haven't given you this value. So write down the dissociation constant for formic acid at 25 degrees centigrade is 2.1 into 10 raised to power minus 4, 2.1 into 10 raised to power minus 4. What I'll do now, I'll simply substitute these values here. 2.1 into 10 raised to power minus 4 divided by 0.01. On solving this, 2.1 into 10 raised to power minus 4 into 10 raised to power कितना होगा यहाँ पे, ठीक है. So this will become under root of 2.1 into 10 raised to power minus 2. I hope you people know how to calculate the root of a number. Everyone knows? Tell me the answer then. If anyone doesn't know, I can explain you how to go with the roots of the number. You want me to explain? Okay, you do your calculation, I'll do mine, okay? Wait. 28 के साथ should come 3 2 16, 7 2s are 14, 6 2s are 12, 36, 6 3s are 18 and 21. 5, 7, 1.45. Okay, what is the answer then? Alpha is equals to 1.41. Okay, you are not taken the 0.1 wala. Okay, fine. Then 1.4 into 10 raised to power minus 2. Otherwise, sorry. It should be minus 1. So, or you can represent this as, अगर मैं minus 1 ना लेना चाहूँ root में तो it will get converted to 0.14. So, this is your degree of dissociation. Now the next was what you were supposed to calculate. We are done with this. Hydrogen ion concentration. Hydrogen ion concentration at equilibrium is nothing but C into alpha. Concentration is 0.01 into 0.14. बताओ कितना आएगा? 0.00. Simple multiplication with 1 and this would be in moles per liter. Now this is clear. अगर आपको concentration ही given होगी, instead of like alpha, if you are provided with the concentration at equilibrium, in that case you will use x. Then only you, then also you are supposed to minus that from the initial concentration. For example, beta alpha is the degree of dissociation. For example, let me say alpha is 1.3%. Generally alpha जब हम देते हैं that means 1.3% has undergo ionization. तो अगर 1.3% इसका जाएगा, to find out the concentration equilibrium, what I'll do कि जो product अगर single product बन रहा है तो the concentration given to us into the percentage given to us, that will give you the amount available at equilibrium. Alpha and concentration must be thinking about why I have not used x, because books पे they talk with respect to x. ठीक है, x, then in that case that depends what does that x, if they have taken that as to be concentration, that will remain x for the products. If two products are there, in that case you are going to minus that from the concentration. If x is the concentration given to you, is given to you, then since initially आपका पूरा amount present, that is why उसको हमने 1 minus alpha करा है. 1 minus alpha. Alpha is the amount that has been produced at equilibrium. Alpha and x are the different things. If x represents concentration, so you will do it C minus x. Okay, that will again you have to calculate what? Alpha. calculate the degree of ionization and the concentration of H3O plus ions if 0.01 molar acetic acid is given to you and the dissociation constant for acetic acid is 1.8 into 10 raised to power minus 5. Same होगा इसके अंदर. Here also you'll use this expression K is equals to C alpha into C alpha upon by 1 minus alpha. This can be avoided because of the concentration of amount of alpha to be very less as compared to 1. So your alpha would be under root of Ka by C. Tell me the value of alpha here. Divided by. Tell me the answer. What is the answer in this case? 4 point something. Yes, 4 point something. It's 4.24. Write down the answer and please do the calculation at your home. Pura, not the approximation. Okay. It's 4.24 into 10 raised to power minus 2. This is your degree of dissociation. To calculate the concentration of hydronium ion, you will simply multiply the concentration with degree of dissociation. Okay. Okay, write down this. 0.01 molar solution of acetic acid is 0.01 molar solution of acetic acid is 1.34% ionized. Is 1.34% ionized. तुम लोगों को समझ तो आ रहा है ना? Is 1.34% ionized. Degree of dissociation is 0.0134. If I have not given you this, you can calculate this using with this value also. ठीक है? अभी तो I have like provided you, but if it is not given to you, you can calculate this divided by 100. That would be nothing but your degree of dissociation. Okay? What is the ionization constant? What is the ionization constant? ठीक है? K is C alpha square. बताओ, सिंपल है ये तो. Concentration is 0.01 into 0. Square. What is the answer? Okay. So if you approximate it, इनमें से minus करेंगे. Okay, I think this is clear to everyone. Now we'll talk about certain concepts of acid and bases which has been developed during the course of time when they were dealing with certain substances which were like getting dissolved, and when they were reacting with other substances to give you either a neutral solution or an acidic solution or a basic solution, or when you react them to form a neutral solution. ठीक है? Initially when they were used to talk about acids and bases, the initial concept said acid and base both should conduct electricity. ठीक है, acids are sour in taste, खट्टा होता है, right? They are sour in taste. Bases are bit slippery, like your soapy solution is slippery if you touch. How many of you have like touched sodium hydroxide in lab? Don't do this, otherwise sodium hydroxide का solution is slightly slippery in nature. उसको हम क्या बोलते हैं? That is also known as some kind of a soda. No, baking soda is different from this soda. ठीक है, caustic soda. Okay, so it has a slippery touch. Then what they are saying, if you mix it with a base, the solution will become neutral. If you mix it with acid, that it will become neutral. So these were the observation. This classification was based on certain kind of a test. If that compound passes through these tests, you will put them into acid. Bases वाले test के through जाएगा, तो you will put them under bases. कुछ particular नहीं था कि by just looking at the structure you can based by Arrhenius concept of acids and bases, which was later further revived or renewed by Bronsted and Lowry theory of acid and bases, and this was again revived by Lewis theory of acid and bases. Okay, so we'll start with Arrhenius concept of acids and bases. Arrhenius said that whenever you take an acid or base, or you can say acid or base are nothing but electrolyte, when you dissolve them, they give you positive ions and negative ions. Okay, that electrolyte will give you positive ions and negative ions. When you are talking with acid, so it dissociates to give you H plus ions. When you are talking about base, it dissociates to give you OH ions. So his theory was based on the generation of H plus ions and OH ions. Substance which were giving H plus ions were termed as acids. Substance which were giving base OH ions were termed as base by Arrhenius. ठीक है? So he said compounds or substances which he has taken should have H plus ions, should have OH minus ions, but there were certain compounds which were giving both, like water. Water can act as an acid or as well as a base. So how you are going to categorize that acid will act, water will act as an acid or water will act as a base? So it again become a conditional thing. Okay. So and ammonia when you dissolve in water, ammonia acts as a base. But if you dissolve in some other solvent, it won't act as a base. So if you are taking water as a solvent, your substances will act as an either acid or a base. So that again will depend upon the amount of solvent or the kind of solvent you are dealing with. If water is not taken as a solvent, your concept of acid as base is gone. Okay, you cannot categorize ammonia as a base by just looking at its structure. You cannot categorize calcium oxide as an basic oxide by just looking at the structure. So it again needed some development, which was given by Bronsted and Lowry concept, which said that depending upon the pair of electron available to it, you can categorize that to be an acid or a base. If a system or a species, ठीक है, is capable of donating a pair of electron, then that would act as a acid. If a species can accept a pair of electron, that will act as a base. So it from H plus to OH, it comes down to pair of electrons. If something is capable of donating electrons, that will act as acid. If let me say donating electrons and accepting electrons, pair of electrons, so that will act as a base. Now for accepting electrons, one condition is there that it should have some space, a metal or an atom or a molecular species should, yes. Concept, one second, Bronsted. हाँ, I think मैंने कुछ गड़बड़ करी होगी, that is for sure. ठीक है, तो basically it changed to, or Lewis said कि someone which is like donating electron, that will act as donating, that will act as an acid. But the condition here is that कि जो भी चीज़ एक्सेप्ट करा है दैट मेटल शुड हैव एम्प्टी स्पेस, it should have some place where that excess electron can come and occupy it. If that space is not there, then it cannot act as an acid or base. Second is like the bond which is like getting formed is known as a dative bond or a coordinate bond. Acid reactions जो होते हैं, acid or base reactions are generally